This is the fourth video on section 7.3, double integrals over general regions. So here we're going to look at example 210. The region we're given is a set of the points x, y, such that 0 is less than or equal to y, less than or equal to 3. Y is less than or equal to x, which is less than or equal to 3. And we're going to integrate over that region e to the x squared dA. So I've drawn the region right here. X, 0 to 3, here we have. So y goes from 0 to 3, x goes from y to 3. So our region is bounded by this triangle. Now, this is both a type 1 and a type 2 region. It was defined as a type 2 region. Really, it's both. It's a type 1 and a type 2, but the way it's defined leads us to treat it as a type 2 region. And I did that intentionally. When we try to integrate this as a type 2 region, what happens? The x limits of integration are 0 to 3, the x limits are y to 3, and the y limits are 0 to 3. So when we try to find an antiderivative with respect to x, it's a fairly difficult problem. It's e to the x squared dx. Now we might have played around with this a little bit in calculus too, because we can write the function e to the x as a power series, and so we can write the function e to the x squared as a power series, and we can integrate this as a power series. Probably wasn't a whole lot of fun to do that way. But my point is, remember what we said, this is both a type 1 and a type 2 region. We can integrate it either way and get the right answer, but that doesn't mean that both integrals are equally easy to do. So setting this up as a type 2 region gave us a difficult integral, or a function that was difficult to find an antiderivative of. So we won't do it that way. We'll do it as a type 1 region. So we do it as a type 1 region. Now what happens? Y goes from 0 to x goes from 0 to 3. So we set this up as a type 1 region. So the y limit 0 to x, the x limit 0 to 3, integrate with respect to y first. When we do that, we treat x as a constant. So the antiderivative is y e to the x squared. The y limits of integration are 0 to x. Substitute x, substitute 0, subtract. Now we have the integral from 0 to 3 of x e to the x squared dx. This is also a calculus 2 problem, but a much easier one. Having the x and multiplied with the e to the x squared dx makes this problem easier, because we can simply use substitution if we need to, because the derivative of x squared is 2x. So this is a fairly straightforward substitution, or perhaps at this point we don't even actually need substitution. We can just look at this and say the antiderivative is 1/2 e to the x squared, evaluated at 0 and 3, so substitute 3, substitute 0, subtract. So we have 1/2 times the quantity e to the 9th minus e to the 0, and e to the 0 is 1.